Okay, so we're going to talk about free body diagrams and bridges and stuff. And this is a really simple bridge. We had one of these today, and it did a really good job. Is that a free body diagram?
No.
No, why not?
Because it's a drawing.
It's a drawing. It's way too complicated. It's got too much stuff in it. We don't care about any of that. How would you free body that? Oh, you're going to like this. Like this. That's a free body diagram. That's pretty nice, isn't it? I'm probably not going to take off points if you have the bridge in the background, but you don't have to show any of that. Okay? Remember that the free body diagram is a simplified perspective. Now let me ask you this question. As long as that bridge is supporting the mass, what is true, force of gravity, and we can call that normal force, we can call it bridge force. I don't really care what you call it. It's probably most appropriately labeled as normal force. What is true of those things? They're equal. And what is true of the force of gravity? Well, it's equal to mass gravity. So what is true here? Well, it's also equal to mass gravity. Now, if you happen to know the mass, like if we're asking you to do this at 1 kilogram, 3 kilograms, etc., then you can actually say, and you should, force of gravity equals 1 kg times 9.81 meters per second squared equals 9.81 meters, nope, 9.81 newtons. Because you actually literally know the force of gravity down on the object and the normal force up that the bridge is exerting back up. So you've got what? The bucket. Did we get a mass on the bucket system? Do we need to do that still for you? Okay, we need to do that. And I'll post that to Classroom. I posted yesterday's results as a screenshot. Thank you for the reminder, Eddie. And I'll put in the additional ones that we have today so that you all have your results. What about the point at which the bridge breaks? What is now true? Do not yell this out. What is now true of normal force and force of gravity? At collapse. Talk to one another. Recording. If your bridge supported the test block and the 2 rods, that is some mass, and we'll mass those on the small scale so that you have at least that, because I don't think everybody supported that. A lot of them failed when we got the bucket, but everybody supported, I think, at least the test block and the 2 things, because you have to have a free body diagram for that first mass that it supported, and then what did I say? Bucket and then 3 and then 5 or something?
It just says 3, 5, and final mass.
3, 5, and final. Okay. If you didn't get to 5, you don't have to do 5 because it didn't support 5. So if yours failed and you were holding 4 kilograms, then your final mass at collapse is going to be, your force. So now that you've talked to one another, what is true at the point when this whole thing falls apart? Gravity wins. At the point when your bridge collapses, the force of gravity equals the mass times gravity. Now, do we know exactly what the normal force that's being exerted back up is?
Yeah, I just put it together.
Do we know exactly? Can we say with any definitive certainty force normal equals and put in a value for that? No. Are equal signs our only option in an equation? We have equalities and we have inequalities. What can we say for sure about the normal force? Less than whatever that number is. So you give me an actual honest-to-goodness number here, and what you're going to tell me in your final collapse free body is that we don't know exactly what the normal force is, but we sure know it's less than that. Because that's the point at which your structure begins to accelerate downward. Because the net force at that point is down. Does that make sense? Okay. We're going to stop this and call this just, bridge write-up conversation.